So the basic idea is that load kind of ramps up now pretty quickly, either based on this type of events, or you have this type of season events that you have a daily kind of peak around 9 o'clock where everybody has put their kids to bed and they go to the shopping sites, or there is a TV commercial and people hit that kind of instant link directly. So in 5 minutes you have a peak of traffic. And if that traffic is not really handled, you have the kind of F5 thing, people start to reload, and you get that kind of snowball thing. Things are slow, and it gets slower and slower, and they force site down. So how to avoid snowball? And this could be a paid commercial for, of course, for RightScale. You need to be able to scale your application, and scale it pretty quick. And now it comes down to, could also your application scale the same way as your servers? Not necessarily. Might also be components inside the application like payment, or might single sign-on and things like that doesn't scale. So just scaling by itself on the hardware is not necessarily something that will save you if you get this Lady Gaga Twitter link. So the first thing that we learned here is that peak load equals high traffic, and high traffic equals high volume. And small is fast. So many sites that have experienced this, they have some kind of minimalistic starting landing page that they could put in when they have this type of events. And sending a small page, just maybe twice or a third the size that you have on the normal size page, will save a lot of traffic and also cause less problem for your service, and the end user will load it much faster. So having some kind of backup plan is very favorable to have when you have this type of peak traffic. And of course you need some kind of front-end cache system. We work a lot with Varnish, and we think that's an excellent product and should be included in every kind of server deployment. So instead of wasting valuable CPU time from a classic Apache to serve static content, you need a front-end cache that will do that out of memory with a blazing speed. And doing that static content is something that goes quick. Database access is not so quick. Avoiding direct access to the database is the kind of one-on-one on optimizing a site to take unlimited load. As soon as you have direct access for the database and you get the peak load, the whole site will typically crash. And that's what you're looking for when you do the load testing. A good example of this would be typically when you have this type of media site, you have the 10 most read articles. If every user would do a call to the backend and get the exact summary of the 10 latest articles, every big media site would be in big problems. So what do? They create the kind of a caching layer in between, where they keep the latest 2 or 5 minutes in terms of most read articles, and that's what you're going to get. You're never going to hit the backend layer. So that type of technique to create the middle layer for that type of data, and avoiding people to go directly to the database and execute that separate SQL statement, is mandatory if you're going to survive that type of Lady Gaga or external peak load problem. And this is probably one of the reasons why you see this type of slow sites when you try to press a buy button or something like that. You get into those minutes where there is a peak load and something is happening in the database, and you get escalation of response time. And as a backup plan, if load goes over your capacity, so if you have a ticket site or you have some kind of event site, so what do? One idea is to implement something in the style of Macy's summer sale or whatever. You stop people in the door when you get too many people inside the store. You only have people inside the web that could actually be delivered within the speed of your normal execution. And the rest you put in a holding pattern, either delivered from the application or from some kind of external load balancer that push the data away from your site until you could actually deal with that excess traffic. This is very efficient and a way to actually scale to any type of load. So queuing system is something that could be used and also to create some kind of waiting pages. I mean, actually inform people. We have a case with Arlanda Airport. When you remember maybe the ash cloud when all the airports were closed. A lot of traffic went to those sites, and instead of just having a stupid kind of error message, they actually put up an informative message saying that the airport was closed for another 24 hours. And that was okay for most people to go to that waiting page and then go back again and wait another day before they actually visit the site. So, of course, be prepared. Test the solution before launching it. I mean, this type of peak load problem is something that you don't want the end user to be your QR department on. It's very kind of unfavorable for the reputation of the site if you don't make it. So this is basically the tagline, why you should run load testing. And load testing as a concept is basically generating synthetic load from the internet, mimicking real users against your production site. And then you could figure out if the site is stable, it doesn't leak memory, because you could have a repeated user behavior, and then you also have a repeated transaction volume from your site. In most cases, people will ask, when does the site crash? At what number? The magical number when the site goes down. And that's one type of test, but you should remember that that gives you the peak. It doesn't really help you fix the problem, because the problem will just appear at that level. But it's good to know that number, because that's something that will give you more money if you talk to management. If that number is below what they expect in terms of ticket sales or travel, then you have a problem and that needs to be fixed. More interesting is how, with the load test, you could figure out how to make your site faster, because you could have a repeated load and you could do a lot of A and B testing. And the difference between A and B is hopefully that the B is faster than A. And then doing that over and over with synthetic load will make it much easier to isolate problem, and then making sure that you don't have any bugs in releases that will cause performance problems. And finally, most importantly in this room with RightScale, application scale is something else than just scaling infrastructure. Putting a web server or 2 web servers, 10 web servers, a piece of cake, just adding another server template and scaling that. But if there's a payment system or there's a direct DB access, will that scale the same way? And the only way to figure out is to put pure load on the system and then see how it works. So a lot of our deals right now is actually working this concept. There is some idea of capacity and there is an idea of load. And then you work out the type of A and B testing. For example, with RightScale you test, am I going to do a small, medium, large EC2 instance? If I test 4 of these, will that perform better than 2 of the small ones, and so on? And you could have a capacity planning versus your performance needs. And that's also cost effective, so you don't waste too much CPU power in places where you shouldn't have them. Maybe you should buy 2 varnishes instead of putting in front of the whole thing and then caching static content instead of having 10 web servers. And capacity is something tricky. It doesn't really resonate to the total number of servers. It actually resonates to the lowest common denominator of performance, which might be the database or that poorly configured single sign-on. In many cases, the pure performance then is just that little single sign-on or that component that do the payment. So figuring out the weakest component, the weakest chain to have this TV program set up is one of the key objectives during a load testing in production. So a question to the audience, are you doing testing today? Of course. Yeah. Are you testing versus production? Almost. Yeah, many customers think that's a bit scary, so should I really test? What happens if it crashes? And my answer is it will crash for real users, so what's the problem? The thing is that you don't always have to push it to that crashing point to do testing versus production. If you do it during the dark hours, you can scale up and down pretty nicely, and finding out where the system starts to have problem. Taking to a crash point is actually a bit clumsy if you're a load testing professional. That's something you shouldn't do unless you actually intend to do it. So this is my favorite picture. Chimpanzee. I think that's less than 1% difference in DNA versus a human being. That doesn't mean that you would take the person on a date, even that my wife sometimes called me an ape. It's not something that you would do generically. You could even take a blood transfusion from a chimpanzee, so close are we, but still so different. And my favorite example here is that many people use staging and test as the only way to validate performance. But that's not really the same thing as production. In production is where you make mistakes. In production is where you have maybe more machines and different complex setup. And in many cases much more data. So just testing versus stage won't give you the pure truth. So that's why we differ between functional testing that is fine to do in early stages, and the production testing, that is live load versus the real system. And when you test the real system, you're actually going to know what's going to happen when the real users are hitting it. So shortly, LoTest 101. This is the basic idea about doing load testing. So you have an application and you provide 10, 20, 100, 1,000 users on that line in different types of tests. And for every user you add, you should double the throughput. I mean, ideally you have a 45-degree angle, and if you have that, the throughput is doubling with the load. And doing so, you will go up here, and then no surprise, there is some kind of maximum how much you could push out on every machine, on every system. And when you reach the maximum, there is something happening. Either you have a point of collapse, that the system kind of goes down in performance, or it's just being vertical. And at that point, the performance knee response time just spikes up. So the concept is to test every component in the system individually, like search or log on or in different types of user scenarios. And you test them one by one, and you get this type of load curve. And then you figure out up here, this is probably maybe 10,000 transactions per second, or 200 purchases or whatever, so you have this type of number, or 250 megabit of volume. And at that level you have a problem, and then you identify what's causing the problem inside this user scenario. Is it the search call, or is it the poorly configured DNS, or is it something else? If you have the insight, you get the very easy A and B testing before the next release. You do the same test, you put the graphs on top of each other and see if you could move the knee further to the right. So the behavior in this danger zone is the interesting part versus the kind of the performance knee and the capacity. Removing that point and pushing that to the right and pushing to the same level will actually make your system perform much better. So this is the kind of trick to know where you have your weak spot, identifying them, and have an easy way to do that over and over again, because load testing is infinite story. You're never better than your latest game, and you're never better than your latest test. So the behavior will cause some kind of problem detection from the data. There are bottlenecks, and then you need to come up with a story how to fix them. But first thing, you know that there is a limitation, and then you need to come up with a solution. Is the solution more machine? Is it more hardware, more servers, or do we need to do something with the code? And then you come down to actually getting a resources and some kind of improvement. To do an improvement, you have to have some kind of targets. And one thing is that you could have operation targets, meaning that we should never crash due to load. We should always have a backup solution, and we should have the system tested. This might seem to be obvious, but if even Apple could go down, I'm not so sure that they even had that as a mandate. So taking that type of pledges is something that's very important, having the support from management and IT organization, how to get the resources to fix this. The other thing is if it's performance based on a competitive situation, checking out what's the best website in your class, and should we be better than this web, should be in the same territory. If we have a big marketing budget, a big marketing spending, is that okay if we are 10 times slower than this site when they come to our site? Because the problem with online marketing is that if you have a campaign and they try to buy the stuff on your site and it doesn't work, they will go to competition directly. So you actually will pay for competition in terms of actually leading traffic to that site. So we try to work with our customers, saying that they should have some kind of base level normal, and that should include some kind of volume, and that volume is typically page views or transactions. And on that base volume, there should be targets, like specific targets, like we should have an average of response time better than 4 seconds, and maybe 95% of users should make this purchase within the maximum number of 30 seconds. The 95% is the idea that most of our users should have an experience that we in advance could set up, and we only accept 5% differentiation from this type of number. Otherwise you get this type of this site is so slow, so I can't really go with it. I will go with competition. You get a bad reputation, it's considered to be sluggish and so on. So hating the average response time, making sure that you don't have the bad exception, is the way to work here. Yes?
Do you have any advice for trying to choose targets in terms of, like, you said 95% of users complete this. You go for something like median load time, average?
Yeah, there's a lot of statistics, but I think that you should have an idea that you should have an average or median load time on the actual kind of transaction, and there should be a 95%. That's the maximum that you would allow people to actually have as a pain point.
So you define average or a median, and then you also define a maximum. I mean, it seems like there's always trade-offs in terms of, like, increasing the average, lowering the maximum, and, like, how do you find a sweet spot there?
Yeah, but what you'd like to avoid is that you have a really kind of nice and smooth operation, like 10 hours a day, and when there is a peak commercial, your site is extremely sluggish. That will come out as a nice average, but has a very kind of bad type of 95% time. So some LoTest findings, what you get out of this, besides a stressed out server and maybe some more money for RightScale in terms of buying more server instances. You spot the backend calls. I mean, caching and static content is lightning fast. The service doesn't have a problem. Avoid the single point of failures in terms of having database calls that goes directly through all the way, and it's very sensitive to load, and that will be immediately detected when you do the load test and putting a lot of load in a short time frame if the database doesn't respond. So you get away with it when you have this kind of weak load and spread out, not when you have that 5-minute interval where everybody's pushing the button at the same time. And content delivery, of course. Again, Varnish is an excellent choice. Why waste dollars on server templates that just push out static content? If you could do that on front-end caching, that would do maybe 5 or 10 times the job for the same type of hardware. And if you have latency problem and testing from different regions, not only for the US, you should check out how to get the content closer to the end user. If the end users are in Europe, then you should have CDN in Europe, or you should have hosting in Europe, and not trying to push it through a fiber cable over the Atlantic. And then on the web infrastructure, I mean, checking out every component, how they work. Is the load balancing okay? Are all servers having the same load? That's the typical kind of beginner's error that you see, that the 4 service is doing fine and the 5th is just idling, or one of the 4 services doing the majority of the load. What kind of server model is optimal? Should we have the large, medium, or extra large instance? Doing testing around that will give you an A and B approach, and also make it easy to change versus maybe in advance for an expected event to upgrade to the bigger service and then go back to the smaller one again. On the bandwidth side, trying to avoid to have images and content that's really big. Making that more trimmed will save load time on the end user, and also making it much easier to distribute the content. And around nice features like scaling and failover, yes?
Keep going.
Yeah. Failover is a bit tricky because if you have an incident and a server goes down and the whole system goes down, and if you have a lot of load, it's very different to take the system up. It's like trying to swim under the surface and somebody's sitting on the top and hitting you on the head every time you put your head above the water. Yeah. But scaling and failover, I mean, it's a bit surprising if you have something and you put it out in the market and then you expect it to work. The only time you have tested it is in real life, when you have a major incident, and that's when it's going to work flawlessly. It's not going to happen. So if it's going to work flawlessly in terms of failing over between data centers and data being kind of up in the right time, you need to test to see how that works. There's all sorts of implications about doing this in a good way, so implementing this type of data center redundancy is a major task, and will require some real load also to see how it's going to be working in real life, because in most cases things happen when you have high load, and then it has to be working without transitions when you have putting load on the system and still has to move it between different types of operators. So this is a back on knowing the numbers. So this is actually a site that's fairly known, it's working fine, and then there is a date, the 3rd, and it's actually when they issue the Nobel Prize. So then you have a spike of traffic towards this site. You can see here that the impact on the actual average and mean are not so much, but standard deviation goes through the roof. So if you only have one value to work with, it don't give you the entire truth. So having all of these components will give you more measurement and more exactness how to work. So by the numbers, you need some kind of baseline. What's the typical value of end user response time? And you need to have some different user scenarios. So you could differ from just loading the start page or doing real transactions. And if you then have the difference between average and the most common value, median, and standard deviation, you have something to work with and to see, detect those type of strange patterns and behaviors. And then if you provide SLA based also not only on uptime but based on response time, then you're getting down to something that's a bit harder. In most cases, SLA is almost server uptime. But if you have SLA on response time, most vendors would be a bit, maybe not so good. But that's something that I think that will be the next trend, that you need to force in the industry, that you have response time SLAs. Anyway, this is a summary of these values. You have the mean, the arithmetic mean, the minimum and maximum value, standard deviation, and 3 sigma. That's 3 times standard deviation. So that's a good way to figure out that 95% level, meaning that in this case you would see that hopefully 95% is better than this type of values. And you could create a trend at a baseline and see if your own success is causing problem, because you could have more and more users and then response time will start to degrade, and after a while you really are in trouble. But detecting that early is something that's really crucial in order to make adjustments, especially on code if it's needed. So web performance monitoring for the cloud is something that initially is just up and down, basically what you would have in a typical kind of server template environment. The application layer will give you much more on how things are working in the real way, and then you could create scenarios that will also have functional testing. Could you actually make the purchase not only that the service is up? And then you get the analytics with response time and also detecting if end users having problem based on latency and other issues. Adding application on the inside will give you more. Then you have monitoring on the actual application, what kind of SQL server calls and so on, and correlating that with the browser end user response time will give you indication on where the problem are. And finally, if you could make the correlation also push data back to, for example, the RightScale monitoring system, you could actually scale based on end user response time. That would be pretty nice.